So we're going to talk about categorization of numbers. Remember, you have real numbers as all the numbers possible, right? Then we have rational numbers and irrational numbers. If it's rational numbers, it cannot be irrational numbers. The two are different, okay? Irrational numbers are these numbers right here. You got to convert the square roots and the fractions into decimals. If the decimals have no pattern, they're irrational, okay? Like pi, for example, is 3.141592, blah, blah, blah. There's no pattern. Square root of 2, square root of 3, this is what it equals to, right? And there's no pattern, right? Rational numbers can be fractions, decimals, but what do you notice with the fractions? What do you notice with them? Well, once you put them into a decimal, are the decimals do have a pattern? Like 1A, 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 right? Or if they don't have a pattern, what do you notice about the decimal places? How long do they go for? Do they stop or do they keep going? Well, no, they stop. Do you see how this one is 0.875? So it stops, right? This one's 0.75. It's the thousandths place or the hundredths place or the tenth place, right? Yeah. Do you see the difference there?
Yes.
Okay. So that's the difference between rational and irrational numbers, okay? But
Yeah.
to determine that, you got to convert them into a decimal from a fraction and also from a square root, okay?
Yeah.
Square root will be harder to convert because you have to use a calculator. If it's like square root of 2, for example, it's not a perfect square. You will have to use a calculator, okay? Yeah. Now let's take about rational numbers, okay? Starting with the smallest rational number is a natural numbers. What do you notice the difference between natural numbers and whole numbers?
There's no zero.
Yeah, natural numbers are the smallest category. No zero, all positive numbers, no decimals. 1, 2, 3, 4, 5, 100,000, right? Cannot be negative. Nope, those are natural numbers, okay? Whole numbers starts at what? What's the difference between whole numbers and natural numbers?
That's not zero.
Yeah, starts at 0, but no negative numbers, okay?
Yeah.
When you have negative numbers, what kind of numbers are they?
Rational numbers.
No, they're integers because those can be negative numbers, okay? With integers, no decimals. Like this right here, when you see a square root of 49, you got to convert it and say, what is it in decimals? That will be a 7, right? Yeah, so no decimals. When you have decimals and they have a repeat of patterns and they're shorter, it's rational. If there's no pattern and it's very long, it's irrational. Do you see that? Both rational and irrational numbers go under real numbers. Any number will be a real number. Does that make sense? Yeah. Okay. So, hold on a second. Let's see here. So that is a difference, okay? Yeah. That's great. Come on, keep working. This is done. Okay. So then we have this one right here, right? First thing I want you to do is I want you to convert all those numbers into decimals, okay? So for example, what I mean by that is square root of 2 is, here's a calculator. What does that equal? What does that equal to? Do you have a calculator over there? I already know this is going to be like very, very long and there's no pattern. What would that be? Square root of 2.
One 1.41421 3.
Blah, 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 blah. There's nothing there, right? So this is definitely not going to be any of the ones on top. It's going to be a rational number. And so, so we're just going to put yes, no, 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 yes. All of these numbers are real numbers, right? So they're just going to be yes for all of them.
What are natural numbers?
Natural numbers are like these ones over here. So you might want to put like a little notation or something, so that way.
Everything is a real number, right? Mom?
Everything is going to be a real number. Yeah, so that's why I put yes for all of them right here. Do you see that? Okay. Okay. If you take a look at this last one right here, do you see this right here? There's no pattern. It just kind of continues like nonstop.
Yeah.
So that's gonna be an irrational number. So the everything else here will be no. Okay, then what is -9 divided by 3 gonna be? I'm gonna put that into a decimal.
It's like 3.3.
So what's 9 divided by 3?
What?
What is
Oh,
-9 divided by 3?
Negative.
It's a negative number. So which one of these would it be?
A natural number? Or no?
Go look at this again. Look up.
A whole number, a rational number, and a real number.
Go look up over there. So which one would that be? Which one do you think that is gonna be? It's a negative number.
Yeah, okay, it's no, 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 yes, no, yes.
Okay, good. So it's integer, yes? It's an integer. It's an integer, which means it cannot be a natural number. It cannot be a whole number, but it could be a rational number, and it's not an irrational number. Because look, if it is in here, for example, do you see how integer is in rational number?
Yeah.
So if it's an integer, it's a rational number. But is integer in whole number?
No.
No. Do you see how that works? Okay, go on to the next one. Okay, next one is, do you see how there's a little sign up there, the little bar? Yeah, it means it repeats. So that means it's a decimal, so it can be a natural, not a whole number, not an integer, but it is a rational number. If it's a rational, it cannot be irrational. They have to be different. Does that make sense?
Yeah.
Okay, so let's go on to the next part. Okay. So 0 is not a natural number, right? The 0 is a whole number, right? If it's a whole number, it's an integer. If it's an integer, it's a rational number, but it's not an irrational number. Because remember, if these two, if it's an irrational number here in yellow, it has to be opposite with the rational number in green. Do you see that?
Yeah.
Okay, because it can't be both. Okay, so these two has to be opposite. Do you understand?
Yeah.
Okay, next one. So then square root of 64. What is square root of 64 equal to? Like what times what? Yeah, it's 8, right? That's a natural number, which means that circle is in a whole number. That's an integer. That's a rational number. It's not an irrational number.
Yeah. I got that.
Okay. So next one. Negative 0.123. That seems pretty small, right?
Yeah.
So let me see. Negative 0. I don't know. This one's not telling me if it is or not.
I put it as a rational
I
number.
think it is a rational because only 3 decimal spaces. So I think it is.
If I get it incorrect, then
It's a rational number. So if this is a rational number, okay, so yes, that means that's a no, right?
Yeah.
But that's a no, right?
Yeah.
Okay. Then let's take a look at what is a pi? You know pi is what?
like 3.
Yeah, it's definitely a irrational number. Okay. And also it might be good if you just memorize this. Just remember irrational numbers square root of 2, square root of 10, pi, square root of 3. Does that make sense?
Yeah.
Okay. All right. Negative 5/2. What is that in decimals?
-0.5. Negative 2.5.
Yeah. So if it's a negative, you know that doesn't be an integer, but it's not a whole number, so it has to be only a rational number. So no for everything else except for yes for rational number.
Okay. Okay.
Okay, next one. What do you have?
-4.
What is that? -4. Okay, that's an integer, right?
Yeah.
So if it's an integer, it can't be a whole number because that circle is not in it, but it's a rational number, it's not an irrational, right?
Yeah.
Okay. Okay, next one. 17. It's a natural number, right?
Yeah.
Yes, but no. Okay.
Yeah.
All right, here we go. Place each number in the portion of the Venn diagram. 4.4, where did you put that? Did you do that one yet? 4.4.
I put in like whole number.
It's not a whole number. 4.4 is a decimal. It cannot be a whole number. Do you see that? Where would it be? It would be under rational number. Next one. What about that right there? 2.55 or 0.2555.
Just a rational.
Yes. Okay, so rational number. So I'll put -0.2555. What about that?
Rational number.
Yep, I think so. That sounds good. Okay. Then what else?
2 pi/3 is irrational. 1.12345 is irrational. -2/3 is rational. -1/2 is rational. 11/10 is rational.
Okay. Okay. So this is a -0.5, right?
Yeah.
That's irrational, right?
Okay.
What's -2/3? What is this? What does that equal in decimals?
0.5. Or no, that's 1/2.
So this is also a rational number. So the 1.12345, that's a rational number as well. Okay. It's a rational number according to AI. Because there's a patterns 1, 2, 3, 4, 5. Although I don't know. So you might want to ask your teacher, okay?
Okay.
I don't know, actually. It is it's a rational number.
Okay.
That's what it says. Because there's a pattern, like, 1, 2, 3, 4, 5, 6, 7, 8, right? There's a pattern, right? Okay. Now let's take a look at 2 pi/3. I think that's an irrational number. 2. Where's the pi sign? So let's try this. 2 pi divided by 3. Yeah, that's irrational, right?
Yeah.
So that'll be 2 pi/3. Then let's take a look. The other one was 2/3, right? -2/3. So -2 divided by 3. Oops. 2 divided by 3. There's a pattern, so that's irrational. right? -2 over 3. Okay, that's also rational. So this is irrational. So make sure you see the difference there, okay? And then the next one is 11 over 10. What did you get for that one? I told you to convert it. Make sure you do it. I'm not doing this work for you. Convert it. What is it? You're not even on the right page. Where's your page? What did you put for this one? I want you to write the equal sign for those, please. Write down the equal sign so that way you know. If I'm going to go through the work with you, I don't expect you to sit here and just be lazy about it. Do you understand?
Okay. Okay, I've put it.
Go to the next page. Is this the other page?
Yeah.
Did you do it?
Yes.
Okay, read the question for me, please. Read the instructions for what do I have to do?
Give an example for each property. Write this in the boxes.
Okay, what is your answer for the first one?
A plus for commutative, I said a plus 5 is equal to 5 plus b.
I understand, but you're supposed to give me the property. What is your property here?
Yeah.
Oh, okay, I see what you're doing here. Okay. This part right here, you're supposed to write it down. So I know, but what did you write down?
Plus 5 is equals 5 plus 8.
Okay, perfect. Commutative multiplication, 8 times 5 is the same thing as 5 times 8, right? What's your associated property?
Associated property. 2 parentheses 2 plus 3 plus 5 is equal to 2 plus parentheses 3 plus 5. Does that work?
Yeah, do you have exactly how I have it? They're in order like ABC equals ABC. The only difference is that the parentheses in different spots. Okay, associated property 2 times 3, 5 equals 2 times 3 times 5, right? Identity.
A plus 0 is equal to a.
Okay, and what will be the identity here?
A times 1 is equal to a.
Inverse. What did you use?
Inverse 14 plus negative 14 is equal to 0.
Good. What did you do for the next one?
14 divided by 14 is 1.
Times 1 over 14 equals 1 times 1 over 14. Because of multiplication, remember? Yeah. But it's the same thing, same idea. Okay, then what?
Closure, I did 3 plus 2 is equal to 5. 3, 2, and 5 are all whole numbers. for closure, multiplying, I did 3 times 2 is equal to 6. 3, 2, and 6 are all whole numbers.
Mm-hmm.
One property that involves with both addition and multiplication, distributive property of multiplication over addition. A parentheses B plus C parentheses is equal to AB plus AC.
Okay. So adding two numbers together gives you a number in the set. The set of integer is closed under addition. Adding two integers can give you another integer. I don't understand what that means. What does that mean? Are you supposed to give an example of that? Okay, the product of 0 and any number is 0. So this one you just do 4 times 0 equals 0, like that, okay? And with this one, closure, multiplying two numbers together gives you a number in the set. The set of integer is closed.
I just said 3 times 2 is equal to 6. 3, 2, and 6 are whole numbers.
That's fine. Yeah, that sounds good. Yeah, just make up something, okay? All right, let's see. Number one, what do you have? One property that involves both addition and multiplication, distributive. Oh, okay. So this one, you could just do -4 times.
I did A parentheses B plus C parentheses is equal to AB plus AC.
Good, okay.
Okay.
Hold on. The product of a number and the sum of two numbers. Product of a number and the sum of two numbers is the same as the product of each number. The product of a number. So the product means you have a number, so 2, and the sum of two numbers. Sum of two numbers, so let's say 4 plus 1, right? Is the same as the product of each number. So 2 times 4 plus 2 times 1, which is 8 plus 2, which is 10. That's what I'm thinking it's asking you to do. Okay.
Okay. Name the property shown by each statement. First one, I said associative.
Property of addition is what you need to put. Property of addition, okay? Number 2?
Commutative.
Property of addition, just put POA. Okay.
Number 3, associative.
Number 3 is not, it's commutative. Associative have 3 terms, A, B, and C, okay? And they're in order, A, B, C equals A, B, C. The only change is the parenthesis. Commutative, property of multiplication. There you go. Okay, number 4?
0.
Something happened here, I don't know what happened. It is 0 property of what? What is the actual name, though?
Property of 0.
I don't really think that's the name.
It just says 0. The product of 0 and any number is 0. So can I just say product of 0?
I think it's 0 property. 0 property of multiplication. She needs to go ahead and write the correct terminology down. I know that's not your fault.
Actually, that makes sense.
Make sure you put that down so that way you know how to write it correctly. It's not just a 0.
Okay, I put POM.
Okay, thank you.
5. Commutative.
Okay, so 3 plus 5 is the same as 3 plus 5. It is commutative property of addition.
Okay.
Because if you think about it, if you do 3 plus 5 equals A, right? Then you replace this as A plus C equals C plus A. Does that look a little bit better? Like A plus C equals C plus A?
Yeah.
Yeah, so then it's obviously commutative, right?
Yeah.
Okay, number 6.
3 times -6 is an integer. No, it's not.
It is. It's -18. Property of multiplication. I guess just property of multiplication. I don't know. I just think that's multiplication. Yeah. Okay. Next one, number 7.
Inverse property of multiplication.
Okay. Number 8.
Distributive property of addition.
Okay. Number 9.
0 property of addition.
Good. Number 10.
Commutative property of addition.
Okay, number 11.
Associative.
Yeah, do you see how the 5 is exactly in the same spot?
Yeah.
The only difference is that you have x plus y. So sometimes it's better if you write on the side. It's the same thing as y plus x.
Yeah.
So if you look at this, it's not associative. What is it? It's commutative. Property of addition.
Um, 12 is distributive property of addition.
What do you put? Oh, it's distributive, right?
Yeah.
Property of addition. Okay, what's number 12?
A distributive property of
Number
addition.
12?
There's two number 12s.
Yeah, I can see that. Second number 12.
0 property of addition.
Okay, that's fine. Okay, number 13.
Identity property of multiplication.
Okay, number 14.
Inverse property of multiplication.
Good. And then number 5.
What?
Number 15.
I actually don't know.
Okay, -3 plus w is a real number if w is real.
I don't know what that means.
I don't know. Closure property. Just put closure property. So it'll just be this one right here. Although she put closure, but she really needs to put closure property. Okay. Next one, number 16.
Commutative property of addition.
This is this one right here. Commutative property of addition 7a6. Good. Okay, next one. Or no, hold on. It's not. Is it commutative property? Oh, it is. Oh, well, no, hold on. Let me see. Okay. If 7 plus a equals k, let's just say it that way, okay? Then this is k plus 6 equals 6 plus k. So it is commutative property, right?
Yeah.
Because sometimes they do that to like kind of mess you up a little bit, but if you replace that with a letter, then it looks easier to look at, right?
Yeah.
Okay, next one.
17 is associative property of addition.
Yep, yep, good, looks good. Associative property of addition. You need to make sure you study for this because you have your test tomorrow, okay? All right, cool. All right, you guys need to go to bed. Quentin and Maddox, we need to go to bed, guys.